Okay, here we're going to look at solving this differential equation. So we have a second order linear differential equation. This one is non-homogeneous. Notice that I have this function on the right-hand side here when it's written in standard form, non-homogeneous. And so this is the first example video I have for solving one like this. All right, so we've talked about how to do these in class, and we did some simpler ones in class, but this one's a little bit more complicated than some of the ones we looked at before. But the logic is always the same, whether the problem is simple or complicated. You're going to start by solving the homogeneous differential equation. So you're going to start by writing down the characteristic polynomial. Find the zeros of that characteristic polynomial. So this one easily factors into r minus 2, the quantity squared. So you get r equals 2 twice as the zero for that characteristic polynomial. So you can find your solution for the homogeneous form of the differential equation if the right-hand side had been equal to 0. So I'm going to label that YH. Our textbook sometimes likes to label that YC. But the solution for the homogeneous differential equation will be C1 times e to the 2x plus, because it's repeated, I'm going to multiply my second solution by x. So C2 times x, e to the 2x. So we've been working on just doing that for a while, solving homogeneous differential equations and writing down the general solution for those. But what we want to focus on for this one is what do we do in the non-homogeneous case. So we've looked at some of these. We have a couple different methods for solving this. We're going to use the method of undetermined coefficients. And so that's basically guess, make an intelligent guess about the solution and then figure out what makes that work. So when I make that guess, I'm going to be looking at the form of these functions on the right-hand side and knowing that when I have a particular solution satisfying this part of the right-hand side, that the function and all of its derivatives are going to have to include these. The linear combinations of the function that's the solution and all of its derivatives will have to include these functions here. So I'm going to have constant function and e to the 2x functions. So my naive guess for this problem might be to guess yp equals a constant term and then an e to the 2x term. So this is my undetermined coefficients that I have here. However, when I look up here and notice that my YH involves e to the 2x, we know that we need to modify this guess, in particular this term of this guess, because my e to the 2x in my guess here is also part of my homogeneous solution. So I'm going to multiply just this term. I don't need to multiply all the terms on my guess, just the terms that are involved in the duplication with the homogeneous solution by a power of x, that is the smallest whole power of x, to avoid duplication. So notice that I have an e to the 2x and an x e to the 2x in my homogeneous solution. So I'll be multiplying this term by x squared. So I'm modifying just the one term. So I started with kind of my initial guess, and then I modified my guess. I'm going to clean that up a little bit here since we're going to take some derivatives. I'm going to put the x squared in front of the 2x there. Okay, so there's my guess with the modification based on the duplication of this e to the 2x term with what's in my homogeneous solution. Now I need to take the appropriate derivatives, so 2 derivatives here, and then we'll be plugging into the differential equation so that we can determine the values for a and b. All right, so the first derivative, I'm going to have b. I'm going to go ahead and just use some parentheses here. So I'm going to have b times, and then I'm going to need product rule here. So 2x times e to the 2x plus x squared times the derivative of e to the 2x. I'll get an extra factor of 2 in that from chain rule. So 2x squared e to the 2x. And then for my second derivative, this b out front will come along. And I'm going to have some more product rules going on here. So from this first one, I'll have 2 times e to the 2x. And then I'll have a 2x times the derivative of e to the 2x. So there'll be another 2 there. So 4x e to the 2x So those two terms came from doing product rule on this first term here. And then when I find this derivative, we're going to have a plus 4x e to the 2x and a plus 2x squared times the derivative of e to the 2x. So there'll be another factor of 2 in there from chain rule from that derivative. So plus 4x squared e to the 2x. All right, these two terms we're probably going to want to combine when I go ahead and plug that into the differential equation. Let me go ahead and do that here so I don't forget to do it later. One of the things about doing these problems is about kind of getting through the steps, knowing what the steps are. But then the other part of it is sort of knowing your own habits enough to know where you're going to make a careless mistake if you're not careful. I know if I didn't combine those terms right here, I might forget one of them as I go into that next step. So you just have to pay attention to your own habits and know where you're likely to make mistakes and use strategies to avoid those kinds of little mistakes. All right, so I've made this guess, and now what I'm going to be doing next is I'm going to plug this guess into the differential equation, and that will allow me to find my values for a and b. All right, so in place of y double prime, we're going to have all of this. I'm going to go ahead and multiply my b through as I do that. So when I plug into the differential equation, I'm going to go up here and do this. We're going to have a big, long kind of thing here. I'm actually going to stack some of the like terms up here. So y double prime, I'll have 2b e to the 2x plus 8b x e to the 2x plus 4b squared, I'm sorry, bx squared e to the 2x. Make sure you get the right thing squared there. All right, so that is all from plugging all of this into my y double prime. And then I'm going to take minus 4 times y prime. So this is another place where I know I'm going to mess this up if I am not careful about it. So I'm just going to do a little scratch work over here, and I'm going to put next to this a minus 4, and maybe in a different color, to help me remember that when I plug this in, I'm going to be multiplying this y prime through by this minus 4 from my differential equation. So it's just reminding me that I have to multiply all the way through by the minus 4 and not just part of it. I know that I tend to make a mistake if I don't do that. All right, so minus 4 times this, we'll have a minus 8b x e to the 2x. And I'm going to go ahead as I plug these things in and stack my like terms. You don't have to do that. You can write it all the way out across. Our textbook does this sometimes in some of the examples too, where there's a lot of terms where they will stack the like terms because then it's easier to combine like terms and do the cancellations when you do the simplification step. So I'm going to have a minus 8b x e to the 2x and a minus 8x squared bx squared e to the 2x. Right, so that's what I get when I plug this in for y prime and distribute through the minus 4 in front of that. And then I'll have plus 4 times y. So I'm going to be taking 4 times my y. And I'm going to go ahead and put that in. So I have a plus 4a. That's not a like term with any of these others, so maybe I'll just put that here at the end. And then a plus 4bx squared e to the 2x. So since that's a like term with these, I stacked that there. All right, so that is all the left-hand side of the differential equation. And so I'm going to have all of that is going to be equal to, when I add all of these terms together, that's going to be equal to 1 plus e to the 2x. So again, you can stack these terms so that they're lined up if you want. The 1 term is a constant term. That's what this 4a term is. So equals. I've written the addition here sort of like you write addition in elementary school where you stack numbers on top of each other and add that way. So 1, and then the e to the 2x term I'm going to put over here. And I should probably put a plus in between them so that those terms are like that. So I've stacked my addition here just basically to make it easier to combine the like terms. You can write it all the way across. Another thing, though, that's hard on these problems sometimes is just not losing a term. So you just want to kind of be careful, make sure something doesn't disappear this is a place I know that I tend to make a mistake if I'm not careful. All right, we should expect some cancellation for some of these. So these ones will cancel, and these ones cancel in this problem. It's different in every problem, so be sure you check with what cancels. That was hard to see there, so let me mark those darker. Cross those out, and these three. All right, and so then I'm left with, on the left side of the equation, I have 2b e to the 2x plus 4a. I'm going to go ahead and write that equation down across here. You don't have to do that, but I just want to emphasize what we're really looking at here. On the left side of the equation, these are the two terms I have left, and then on the right side of the equation, I'm left with e to the 2x plus 1. All right, and so if this equation is true for all values of x, that's what it means to be a solution to the differential equation, then my coefficients have to match. So this 2b that's here has to match this coefficient of 1 that's right there. So I'm going to have 2b equals 1, or b is 1/2. And then the constant term for a is going to have to be equal to 1, or a is 1/4. Okay, so that gives me my a and my b for my particular solution, my yp. So I'll go ahead and write the yp down here. So I'll have 1/4. Make sure you put the right numbers in the right places here. So a is 1/4 and b is 1/2. Okay, so if what we're after is a general solution to the original differential equation, essentially you've got kind of two parts of the problem. The part where you're finding the homogeneous solution using the characteristic polynomial, and then the method, whatever method you're going to use to find the particular solution based on the right-hand side, the functions that are on the right-hand side. So I use the method of undetermined coefficients. We also learned a method called variation of parameters, which is in general a little bit harder. So I usually tend to go with this method when it works. But you could use either of those methods to find the particular solution. If what you're after, though, for the original differential equation is the general solution to the whole differential equation, then you're going to have the sum of these two, the yh plus the yp. When you do the online homework, be very careful that you pay attention to what it's asking you to type in which box. It might ask you for the homogeneous solution first, and then the particular solution, and then the general solution, or it might just ask you for the general solution. So just pay careful attention to what it's asking you so that you know which part of it you should type in the box. When you're doing the problems for me, for exams or written work, I usually will ask for the whole general solution. And so, you know, that's probably, you're not ready to stop until you get there. So just pay attention to what the instructions ask you to do.